Good morning or afternoon. What we're going to be doing today is solving quadratics by factoring. Now this is a new unit, so make sure you pick up a new unit table of contents. The title is Quadratics and the unit number is 5. So again, make sure you pick up a new table of contents because again, this is a new unit. So to start our unit off, we're going to start solving quadratics. So we started factoring last week, Monday and Tuesday of last week, and now we're going to take it a step further. So our first notes today is solving quadratics by factoring. So hopefully you picked up one of these little strips. You're going to end up gluing that down into your notebooks and go ahead and pause and write these notes out. Alright, so you've written the notes, and the notes say here that in order to use this product property, the zero product property, the equation must equal 0. And then the equation must be factored so that you can set each factor equal to 0. Because I know if something is being multiplied and it equals 0, one or both of those must equal 0 for this statement to be true. So here's our first example. Right now I see that is not equal to 0. So I need to make it equal to 0. So I'm going to subtract the 9x over. When I subtract this 9x over, I need to make sure to put it in the correct order. So it'll be x squared minus 9x plus 18 now equals 0. I also need to make sure it's factored, which right now it is not factored. So I'm going to do my x right underneath. This is what we learned last week. So this is the part that we learned last week. The top part of your x should be your AC, which is 1 times 18, which is 18. It's the top part. The bottom part points to your middle, negative 9. Draw our line, and we put the leading coefficient on top of this line. So 1 and 1. Alright, so now I've got to solve the puzzle. I need to figure out what multiplies to 18 but adds to negative 9. So that's the part that you got to think. What multiplies to 18 but adds to negative 9? Negative 6 and negative 3. Negative 6 and negative 3 both multiply to positive 18 but add to negative 9. Okay, so now I have 1x minus 6 times 1x minus 3. Because I'm not able to reduce those, so it's the top part gets the x. So 1x minus 6, 1x minus 3. And bring down my equals 0. Okay, so now I'm ready to use the theorem. The theorem says that I can set each one equal to 0. So now I turn this one problem into two problems, and I'm going to solve. Add 6. So this one is x equal to 6. I'm going to solve this one by adding 3. X equal to 3. Those are my solutions. So x equals 6 and x equals 3 would solve this equation right up here. It will make the equation equal to 0. Alright, the next one. 2x squared plus 6x equals negative 4. Again, I need it to equal 0. So I'm going to add the 4 over. Okay, make sure it's in the correct order. So it needs to be 2x squared plus 6x plus 4 equals 0. Now I want to factor it. Now some red flags are going off in my head because I see a whole bunch of numbers here. I want to check for GCF first. And sure enough, there is a GCF. 2, 6, and 4 are all divisible by 2. So I can take out a 2 from everything. So that leaves me with x squared, 3x plus 2 equals 0. Alright, now I can factor this part. So the top part points to your outside, which is 1 and 2, which multiply to 2. Bottom part points straight to the 3. Draw my line. My leading coefficient is 1. We're ignoring this 2 because we already took it out. So just ignore this 2 in front. So my leading coefficient is 1. Now I've solved the puzzle. What multiplies to 2 but adds to 3? Well, hopefully you know it's positive 1 and positive 2. Ask yourself, can you reduce? No, I can't reduce. So I bring down this 2 and I have x plus 1. And then on this side will be x plus 2. Whatever's on top gets an x to it. So it's 1x plus 1, 1x plus 2. And then I have to bring down the equals 0. Now, when I use this factor theorem that was up there, I don't need to worry about this 2 because it doesn't have x in it. So it's not going to do anything. I just have to do x plus 1 equal to 0 and x plus 2 equals 0. So this step here is the new step. Alright, to solve this, I subtract 1. So one answer is x equals negative 1. Subtract 2, and the second answer is x equal negative 2. So I've got my two answers. Okay, so that's solving by factoring. So you factor it out and set each factor equal to 0. You turn one problem into two problems. Alright, the next method is going to go on your next page. So this should all been written on one page. On the next page, you're going to have your solve quadratics by graphing, which this is a printout you should have picked up. But this is what I need you to write. So go ahead and pause and write this definition. Alright, so the definition here says solutions are zeros. The solution or a zero to an equation when equal to 0 is the x-intercept or intercepts since y equals 0. If the graph does not cross the x-axis, then there are no real solutions. So pretty much we're looking for the x-intercepts. Wherever crosses the x-axis is our solution because only when it's equal to 0. Now, if you recognize x squared minus 9x plus 18 was our problem from the last page. We had it equal to 0 like that. So if I go back, here it is, x squared minus 9x plus 18. Okay, this is the exact same problem. So, I'm going to erase that. The answers should be wherever it crosses the x-axis. So I see it crosses 2 times the x-axis. Remember, this is the x-axis. This is the y. This number is 1, 2, 3, 4, 5, 6. So my solutions for this one is 3 and 6, which I can go back and look, and sure enough, I did get 3 and 6. So this is solving by graphing is a great way to check your work from solving by factoring. So the work today, you can check your work by graphing, but you need to make sure to show your work by factoring. Okay, so then this was the second problem we had. 2x squared plus 6x was 4. It's already solved. Technically, when I want the solution, I want to set it equal to 0. So technically what I'm doing is plugging 0 here. And since I'm plugging 0 for y, which is right here, I'm looking for the x-intercept. So I notice it hits 1, 2 times, very, very close to each other. Let's see, this is 0, so then this must be -1, and then the next one would be -2. So my answers were x equal -2 and x equals -1, which if I go back and look, sure was -1 and -2 were my solutions. Okay, so that's solved by graphing. Solving by graphing is when you graph it in the calculator, get a y equal, or get it equal to 0, one of the two, plug it in, and wherever it crosses the x-axis. Now, if it does not cross the x-axis, then there are no real solutions. And remember, we're going to talk about those imaginary numbers. We've talked about them before. We're going to talk about more after Thanksgiving. What does it mean to be imaginary? So if it doesn't cross the x-axis, what does the answers actually look like? Okay. All right. So if you're catching on and everything, you're ready to go ahead and do your worksheet for today. Otherwise, I'm going to go ahead and do a couple more examples just in case. Okay. So here's some extra examples. Looking at this first one, I see a bunch of numbers. So the first thing I think is there GCF? 3, -5, -2. There is no GCF. So I go straight to my x. Now, of course, I didn't put my equal 0. Whoops, sorry. Because if I'm solving, I need it equal to 0. Okay. Now, the top part, 3 times -2 is -6. That's what I put on the top of my puzzle piece, my x. All right, 3 times -2. The bottom points straight up to -5, so I need -5. Draw my line, and I put a at the top, 3 and 3. If you don't remember this, this is what we did last Monday or Tuesday. Check your notes back, because in your notes I went into more detail. All right, so now I've got to figure out what multiplies to -6, but adds to -5. All right, so multiplies to -6 is 1 and 6, and then 2 and 3. Now it has to it has to multiply to a negative, but add to a -5. If I make both of these negative, it adds to -5, but that equals +6, so that doesn't work. But let's see, if I make this a -6 and a +1, that gives me -5, and also multiplies to -6. So there it is, -6 and +1. Those are the numbers I'm going to use. Now if you notice, I can reduce this fraction. This reduces to 1 over -2. So then that answer will be x minus 2. Now this one, 3 over 1, does not reduce, so it would just be 3x plus 1. All right, bring down the equal 0. And now I set up each one. X minus 2 equals 0. 3x plus 1 equals 0. To solve this one, I add 2. So that cancels, and you get x equal 2. For this one, I have a few more steps. I first subtract the 1. So I get 3x equals -1, but then I have to divide by 3. So in this case, my answer is a fraction. Oops, sorry. Looks Kind of funny there. So it'll be negative 1 over 3. Okay, so sometimes you can get a fraction. That means if you check it in the calculator, if you were to go and graph 3x squared minus 5x minus 2, it should cross at 2 and then somewhere between 0 and negative 1 because it is a decimal. Now you can actually get the decimal if you wanted to and make it more accurate if you want to check in your calculator. Okay, but that's how I would do that one. All right, the next one. Again, I check to make sure there is no common factor. So 15, I know the only things that go in 15 is 5 and 3. 5 and 3 do not go into these numbers. So I go straight to the x. All right, the top part of my x will be 15 times negative 2, which is negative 30. The bottom part points straight up to negative 7. Draw my line, 15 and 15. Whatever is your leading goes in the front top. All right, so now here's the hard part. What multiplies negative 30 but adds to negative 7? So 1 times 30. There's no way I can add up that to get me 7. 2 times 15. Let's see, 2 times 15, that can give me 17 or 13, but not 7. All right, so then 3 times 10 is the next one. Okay, 3 and 10 can give me negative 7 if I make it positive 3 and negative 10, which do multiply to negative 30. So there's my answers there. So 3 and negative 10. Now this fraction, I ask myself, can I reduce this? And the answer is yes, I can reduce this by 3. So that would be 5 over positive 1, which means it would be 5x plus 1. Right over here, I'm going to erase this real quick because I got to do the same thing. Ask myself, can I reduce this? And the answer is yes, I can reduce it by 5, which means this will be 3 over negative 2. So then this answer will be 3x minus 2. All right, bring down the equal 0. Set each one equal to 0. 5x plus 1 equal to 0. 3x minus 2 equal to 0. And solve. Subtract 1 and divide by 5. So then x equals, and I'm running out of room, sorry, negative 1 over 5 for one answer. Add 2 to this one so that it goes that way, and you got 3x equals 2. Divide by 3, and again we get another fraction, or what would be a decimal, 2/3. So if you were to check this in the calculator, it would cross at decimal points. It would not cross at whole numbers. So again, to check it, you plug in 15x squared minus 7x minus 2 and y equal, graph it, and try to get as close to where it crosses the x-axis and see if it matches what these fractions would be in decimal form. Okay, hopefully that helps out. Good luck.